Hello, everyone, and welcome back. In this video, I want to talk about the multiplication and division in MIPS assembly language. Till now, we learn how we can add or subtract some data. These are the generic format of multiply and division in MIPS assembly language. As you can see, we have only two parameters, but in all of the other add or subtract instruction, we have three parameters. The first one was the destination, and the second and third parameters or the data that we want to add or subtract. And the answer will be stored in the first parameter. But here we have only two parameters. So where does the result go? In fact, the result automatically goes into two special registers called H, I and LO, high and low registers. These are two specific registers for multiplication and division. So as you know, if we multiply 232-bit variables, the answer can be maximum 64 bits. The first 32 bit will go to low register and the upper 32 bits go to a higher register. How can we get data from this to register? There are two specific instructions for this purpose. Move from high register and move from lower register. This is the general syntax of these two instructions. For example, here we put data from high registers into their registered $2, or here we transfer data from low register to the one of the generic registers. So let me give you an example. For the first example, I want to write a program to read two numbers from the keyboard and display their multiplication. I want to use the previous program and modify it so we have only one result. Here we show the first prompt on the screen. Then we read one number from the keyboard and put it inside variable number 1. Then we show the second prompt message and read another number by using system code number 5. Here, I should multiply this to number. Let me first load them and put them inside two registers. Now multiply $sign to 1. Let me display both of the low and high register content. So I want to display low and high register. We have a system called to display integer numbers. In order to print a number, we should use a system called number1 and we should put the number inside the registered $sign a 0. So by using move from low register, I will send the low register content inside register a 0 and call my system call. Now, I should do the same thing for printing the content of the high register. Show the high message and here move from high register to a 0. Run your program. The first number 10. The second number 5. The low register is 50 and the high register is 0. So, and here, I can run it 100 times. 52. 5200 in the lower register and the higher register is 0. So if you multiply to a small number, your result will be inside the low register. But if you multiply to 32 bits number, the result can be maximum 64-bit. So some parts of the data or answer can be inside the low register and the high 32 bits of your result can be inside the high register. Let me show you an example. Let's multiply to a very large number 1 million times 2 millions. As you can see, the result is split into two sections and some part of the result is inside the lower register and some part is inside the high register. The 64-bit result is split into 232-bit sections. As you can see, when we print these two parts, it's not the same things that we expected, because this is a small version of the high register and this is the small version of the low register. It doesn't mean that you should concatenate this two number to find the result, but in most of the case, you don't need to worry about the high register content. Your result will be inside the low register. Let me modify this code. So I want to read a number from the keyboard and display. It's actually L on the screen. You know that the end factor here is the multiplication of number 1. And I want to modify this code. So, in order to complete the factory error, I need a for loop. It should be a start from 1 to end. Let's see how we can write a for loop in MIPS assembly language. Let me write a factorial algorithm here. Then we convert it to the MIPS assembly in order to compute the factorial. We need to define a variable and initialize it 1. Then we need a loop. Start from 1. Still un. We should multiply f by I. And the result would be a store in f. So I want to convert this code into the MIPS assembly language. Instead of f, I should use one of the registers, for example, as 0. $sign is 0 for the container. I can use another register. So 30 is my loop counter and 0 is the variable f. Now I should multiply this two number. The result goes to low register. You should save it into the F, or in this example $sign is 0. So move from low into last time as Now I should increment the counter at immediate. I should check the look condition. I less than or equal NW, so branch if less than or equal the counter to 0 and the NN is or number is inside the color same V0 counter is less than or equal the input number go to again is the label of this line. After this part complete, the answer will be inside the register $sign as 0 should print it. Let me remove this part. I have a factorial message. First, I want to print this message. I should use this system called but message. And in order to print a number, we should use system call number1. And the number should go to 0. We can use move instruction. Wallerstein is 0. OK. Let's run it. Number 5 and 5 factor year 120, we set it. Number 6, 720. Thank you for watching this video and see you later. OK. Let's write some more practical examples. Assume that I want to write a program to read two integer numbers from the keyboard, and after computing their summation, print the result on the screen. So I need to message I name them prompt1. Also, I need a message for the result. I need to declare two variables to store the input. Number 1/4 variable initialize with 0. It's a 32-bit variable. Number 2, for sum, I need another variable. Now print the first message by using system call number4. And after we show this message, we need to read one integer number. In order to read an integer, we should use a system called number5 and the result will be inside registered $sign with 0 load immediate $sign with 05 and system call. Now I should restore this input number inside number variable. Number 1 is store-bought the answer or is inside the register 0. So $sign with 0. So by this way, I read one integer number and store it in number 1. For the second one, I should do the same thing. So I copy-paste this code. Only instead of prompt1, I show the prompt2 and here I show a story inside the number 2. Run it till this point. As you can see, the first prompt is displayed here. I should enter the first number 1000. Now ask me to enter the second number 2000 and the program terminated till this point. Let's complete our code. We want to add this to a number, but now my number are inside number 1 and number 2 variables. I will load them and store them in some temporal register. Now I will add them. This to register will be added to each other and the result will be stored in $signs history. I will store it inside the variable sum also. Now I want to show this result. First, I want to print this message. I use the system called. And in order to build an integer we should use them all called number 1. The integer should be inside $sign a 0 so load toward a 0 and sum. System called code inside the $sign 0 and system call. OK. Let's run it. Enter the first number, 1000. 2000. And the result is 3000.